Welcome everyone. My name is Asmo Urpilainen. I'm the Chief Product Officer for the French Integration Platform. And I think we have the fifth webinar today in the series of the modern integration platform, where we've had a look through some of the human interaction elements and managed file transfers, some API aspects, and so on. But today our agenda is exception handling in process automation and integration in general. So pretty much this means that we're going to be taking a look at different sorts of scenarios and situations where exception handling can be applied within the French integration platform, and how those sorts of situations should actually be handled and dealt with when exceptions occur in said situations. And of course, the main, I would say, giveaway from the webinar today is, of course, what should we do in these different types of situations where we have an exception occur, and what are the kind of options at our disposal to deal with the exceptions in a nice and a clear way to actually achieve more robust integrations, and of course implement the integration functionality and logic in such a way that we can keep on top of the exceptions and of course reduce them as much as possible. And of course, while we are covering the topic of what are the different sorts of exception mechanisms and situations, and what can we actually do about them, we'll have a little bit of a best practices kind of sprinkled here and there to kind of guide you on your way in creating processes that are nice and robust and are actually dealing with the exceptions in the correct way. We will be probably jumping a little bit back and forth between the presentation here. We'll be covering the kind of basic concepts and of course the mechanisms that we can utilize, but then also to have a short look through on the platform itself on how to actually implement those use cases and how the configuration looks on the platform in order to actually achieve what we're showing here on the slides. But I guess without further ado, we can actually jump to the content at hand here. So different sorts of exception handling situations and use cases that we're going to be covering in the webinar today. And I've kind of split these open into 5 or actually 6 separate categories. And the kind of first one that we're going to be starting with are kind of technical failures inside your integration processes that can be fixed with retrying either the whole integration, portion of the integration, or a specific part of the integration to avoid these sorts of situations. And of course, the ideology here in the first one is that these are typically scenarios and situations caused by kind of network connectivity issues, or there might be corrupted data while we are calling, let's say, a REST API, and for whatever reason the data gets corrupted on the way, or these sorts of, I would say, unexpected situations and errors that are quite typical in integration use cases, for the very reason that if we imagine that we are doing 1 billion API requests every month, it's just the kind of law, or I would say the law of statistics says that all the connections and I would say operations that we use to interact with other systems and integration endpoints are not 100% reliable, meaning that out of those 1 billion imaginary transactions, there is going to be a certain percentage that are going to fail because of these connectivity problems or corrupted data, or there just might be a random error in the source or target system that you are calling that causes that particular, let's say, request or interaction to fail for whatever reason. And of course, what we are trying to do is try and fix that issue without any human interaction, meaning that we have mechanisms in place that are going to expect and I would say take into account that these sorts of issues can and will arise, and we can create the integration in such a way that then this is not going to be an issue in the long term, and the platform will be, for example, be able to fix that issue with a simple retry of that same functionality again and again. But of course, then I've split the kind of technical failures into two different parts. So the first one, and of course most common, are those technical issues or that can be fixed with retries. But then we have other types of exceptions and situations where we can't fix the problem with a retry. And these are typically situations where, for whatever reason, let's say the authentication or authorization that we are using to access the system has gotten outdated, like our passwords or access tokens, or there might have been some configuration done by the sysadmin of that target or source system that causes, for example, some sort of an access control rule to change so that then we can't access the resources that we used to be able to within the integration. And typically, of course, in these sorts of situations where we have all of these different use cases where an integration that used to be working isn't working anymore, and of course we can't fix that problem on the integration platform side, and how can we deal with that and of course catch these sorts of situations that require maybe the updation of that password or token, or maybe we need to contact let's say the sysadmin of the system that we are connecting to actually be able to fix this issue, since these are kind of two quite separate, I would say, approaches, in that sense that the other one we can kind of deal with automatically with the toolkit at our disposal on the Friends platform, whilst the other one is more about just detecting that issue and letting, of course, someone know that now, hey, this password needs to be updated. Then the third option in the tech category here is technical failures, but with a backup plan. And this is probably something that's not quite familiar to many of you. So this means that actually we have the capability of creating integrations that can, in the case of a failure, for example, move on to, let's say, the sort of a backup plan ideology where, let's say, the main system is down. So instead we take a backup system from staging, or we might even, let's say, move the execution to a completely different data center if that data center is down altogether. But basically this means that we can model out a backup plan to come back from an exception situation in certain situations that's kind of similar to retries, but instead of doing the exact same retry, we can automatically try to do the same thing, the same operation, but maybe with a slightly different configuration or against a different system altogether. And then, of course, we have the, I would say, kind of the other or the rest of the exception use cases, where, of course, we could have a situation where we, by design, create our integration in such a way that in certain situations and conditions, we just want to end in the whole integration in an exception situation and kind of manually state that when these conditions are set, an exception should be thrown out from the integration. And this is of course something that's developed into the integration process manually and of course kind of intentionally by the developer. And of course, well, one key aspect of these sort of exception handling situations, which deserves its own kind of, I would say, subcategory, which is kind of, I would say, on par with the technical failures here, and that is, of course, erroneous data. So I would say that maybe 80% of let's say, exception use cases are typically situations where we either have a connectivity problem, so the tech failure that we can fix with a retry, or the data that we are either querying, receiving, sending, interacting with in any other way is just erroneous or incorrect in various different ways. So we might be missing data fields, or the data is just simply in a different format than we expected. And these sorts of use cases where the data that's coming into the platform isn't what we are expecting, and how do we deal with that? And as an added bonus here, I added the silence monitoring errors here as a last, I would say, use case where we can have situations where the integration is not technically failing. So there are no exceptions happening within our integration, but still we are in, let's say, an exception situation, and we are basically dealing with a problem that, let's say, we have an API where someone is sending us orders, but if there's no one sending those orders, we don't have, of course, any exceptions, but the underlying business use case is still not being fulfilled. So how can we kind of detect and deal with cases where the integrations is not failing, but it's not kind of executing either? So how can we detect and deal with that? And of course, these are now the, I would say, 6 different use cases and situations that we're going to be covering in more detail. And pretty much before we kind of jump into the actual stuff here, or actually let's reroute the planned agenda I had here a little bit and actually go straight into this and go to the demo portions here a little bit later. But the first of all, of course, what do we have here in Friends for the technical failures fixable with retries? Is that quite simply that retry option for any given Friends task or a Friends process scope within our integrations. And I'll show you in just a moment how you can enable that retry functionality. But what the retry functionality actually does is that you're probably familiar with how the Friends tasks and basically integrations operate, in that sense that all of the different functions that we execute within our integration process can either end in a success state, which is of course green because green is good, or in an exception state, which is of course then displayed as red in the user interface. And if we enable this retry functionality for a given Friends task or a portion of the process, what that means is that we can choose how many times that functionality should be retried with exactly the same configuration before actually going to that exception state. And that means that we have basically this sort of a quite typical, I would say, retry wait pattern in place here, that let's say if I add in 3 retries for my FTP transfer here. So if the initial transfer fails for whatever reason, we wait 1 second and then try the transfer again. If that fails, if that kind of second attempts or first retry attempt fails, then we'll wait 2 seconds and try the third one, 4 seconds, 8, 16, 34, and so on and so on and so on. And of course, the point that we're trying to kind of make here is that sometimes, let's say, the target system might have a short downtime period, or there might be, let's say, some sort of weird network rerouting going on. And typically, if we just give the integration a few seconds before retrying, it's much more likely to fix that issue. And the way that that behaves in Friends is, of course, now, if we have our, let's say, 5th retry and it still works, that means that we can actually now put the task in a success state and quite simply just display the total time it took for that particular part or task in the process to execute. So if typically, let's say the FTP transfer takes 1 second, but we have to do 5 retries, that means that the total execution time in that success state of that portion of the integration will be maybe around something like 1 minute-ish or 45 seconds, since we are going through that retry loop. And just to kind of maybe jump over to the demo portion here. So the way that you enable this for any given task in the Friends integration process, or of course any scope that we create here in the Friends process, is simply going to under advanced settings and enabling the retry on failure option, where you then have the possibility to say how many times would you like to retry that particular step or portion of the process. And just for your convenience, we're of course displaying that little retry icon there for all of those steps that have the retry functionality configured. Perfect. Moving on to maybe the technical failures not fixable with retries. And this is, of course, also a good segue to 2 specific kind of ways of or generic ways for us to handle any type of exceptions. And what this means is that if we take the same example that we had there previously about that failed FTP transfer, and we could even still have that, let's say, 5 retries to try and fix the FTP transfer problem within our integration process. But even if after five retries it still fails, what that means is that then we have two different options to deal with that error. And typically we use these sorts of approaches now to basically send an alert, create a ticket in your, let's say, ticketing system, or yeah, like I said, to send an alert via SMS, WhatsApp, email, whatever we need. Since, of course, now what this means is that even if we are trying to retry and it won't still fix the problem, we'll have to let someone else know about that particular problem so that then someone can actually interact with the platform and figure out what's going on and possibly like change the password for the FTP transfer itself. And like I said, this is the perfect segue to now go over the two main exception handling mechanisms here. So the first one is, of course, on this sort of a process level, meaning that we are in a situation where we want to define a customized exception handling path or pathway in the visual friends process itself. And the way that we enable that is quite simply with the catch shape. And what the catch shape actually does is that if I'm connecting my delete step here to my catch shape, and I have, for example, my retry option enabled here, after those 5 retries, if it's still failing, basically that particular delete step in the process will go into the exception state, so the red state, and then with rather than stop the execution altogether at this step, we actually split the execution into the catch shape, which now allows us to model out whatever type of an alert mechanism or other integration functionality that we want to enable when this sort of a use case or exception actually occurs. And of course, how can we now utilize this functionality in a maybe a little bit of a nicer way is that if you look at the delete step here and of course follow that to the exception state, we can see that basically we are creating a variable called error, and under that error variable, if I let's say, for example, we could just take maybe read file here just as an example. What can we actually do with that error variable is that the actual exception, including all of the different exception types that might occur in the task or portion of the integration that we are executing, are now available basically for your usage under the normal hashtag variable low code reference. And of course, the error reference there is now referring to the actual error that's being generated by the delete functionality. And what that of course also means is that we can do cool stuff like if we wanted to, we could even detect different types of errors in these sorts of use cases where we could split the execution into 2 different paths here and determine that if, let's say, the variable error contains, I would say maybe we do something like contains timeout functionality or incorrect password, then we could split and send a different type of an alert. And if not, then we could do something else. And pretty much what this means is that we have all of the normal integration functionality within the Friends platform available for us to deal with any type of an exception that we might have. But from the other hand, this can create quite cluttered integrations for you. So if you have a situation where I'm running through a simple one-step process, but my exception handling is actually taking up more space than my whole process, this isn't the most practical approach. And for that very reason, we can actually also create a global error handler that we are actually calling sub-process to call an unhandled error. So what that means is that if I have my exception catch shape present, now I'm actually handling the exception in some way, but if I get rid of that and it still fails, now we end up with an unhandled exception. And if we end up with an unhandled exception, we could actually create a friend's sub-process called error handler as an example that we could utilize to now basically do the alert functionality, do the detection of different error types, or create that business rule set, what should happen in different sorts of error situations, etc., and actually attach that error handler sub-process to the whole integration that we are creating. And of course, what that means is that now we could pass in our, let's say, desired error message, and we have the same variable error available here to configure our global error handler as well. And this basically means that if anything fails in the whole integration flow, so it could be the delete or the move or anything else where we are not handling the exception with the catch shape, basically the integration will stop there and call that sub process to send that alert to let someone know that something is happening now with the integration itself. And of course, as a best practice here, quite typically you should have global error handlers on at least all of your business critical integrations and maybe some sort of alert processes in place to let someone know that now there's a problem, and the task or scope specific error handlers are most likely used when there is a specific use case or a super critical part of the process that you want to create a different type of an error message or a different type of an error handling process for that particular use case. Good. Moving on to maybe process failures here. So now we're taking it to a little bit of a kind of a different approach to the, I would say, exception handling and error handling situation here, meaning that we might have use cases within our integration processes where none of the actual steps of the integration are failing, but they are not producing data that we are expecting them to, or they're just not behaving in a way that we want them to behave. But the technical approach there is that technically the task did what it's supposed to do, or the integration did what it's supposed to be doing. And a good example of this might be, let's say, an SQL query, where we might be querying the top latest products or the top sellers from an SQL database. And of course, now, if we think about the SQL query task or connector in Friends, it's completely possible that no rows are actually returned as the result of my SQL query. And that might mean it's an error, but it might not also mean that it's a problem. So depending on the use case, it might be an exception that we get no products out of our SQL query, but it might be something that we are actually expecting not to find if we are, for example, checking for the existence of some sort of a data row or the result of a query. And in these use cases, we actually want to model out the decision that we use to determine whether, for example, the SQL query here is behaving as expected. And we could do simple stuff like check that do we at least find one row from our top products. And if we don't, we actually split the execution with a normal Friends decision and actually throw an exception out manually from the process. And pretty much the way that we do that in Friends is exactly like in the picture. So if we imagine that we had our SQL execute query step there, and we might be getting some products out, or we might not be getting some products out, the easiest way to do that determination is, for example, to just check for the number of rows, so the count of the rows that we are getting back from the SQL query. And I could say maybe, okay, so if the count is larger than 0, we'll continue. Otherwise, we actually want to create that throw functionality there. So end the process in an exception state manually and stop the execution of that integration in that exception shape. And of course, this allows us to write our own custom exception and basically tell what is inside the var area or the variable error that we are, of course, maybe connecting to a sub-process for the global error handling use case from the previous slide. We also have the option of actually bypassing the kind of sub-process for the global error handler, because we might have use cases that we still want to end the integration in a kind of designed exception state, but we don't want to create the alert. So that's why we can control that functionality with the selector there. Excellent. Moving forward to maybe technical failures with a backup plan. And this is now kind of taking what we've learned in the past few slides. So of course, catching exceptions, what we use to create our alert here in the second step, and also kind of doing decisions based on the data. So what the kind of backup plan functionality here means that we might have now a similar use case where we are getting our top products from our SQL database, and we might even have configured our, let's say, 5 retry options for that SQL query. But regardless if that step fails and goes into that exception state, we can of course then catch that exception exactly like on the previous slides. But now, rather than kind of doing nothing and just sending an alert, we can actually try and recover from that situation by, for example, querying the top products from a separate database, like let's say from staging, or we could even, let's say, have a hard-coded, let's say, backup product catalog that we use if the main system is down to kind of recover and join back to the normal flow of the integration process. But of course, here we, for instance, basically providing you with quite strict validation, which means that the data you are kind of producing from that backup plan, as I like to call it, should of course match what you were expecting to have in the integration flow in the first place. So that means, of course, that the database query should be similar, or the, let's say, hard-coded data should be exactly the same that we would be returning from the actual functionality itself. And of course, this also means that we could now kind of have multiple backup plan options. So we've had some situations where you might want to say that if this fails, let's try staging. If staging fails, let's go for test. And if test fails, then we'll use like a hard-coded, let's say, dummy value, because sometimes, let's say, the integration processes are so critical that it's better to use, let's say, a little bit outdated data or hard-coded backup data rather than doing nothing with the integration in the first place. And similarly, of course, here on the demo side, the easiest way to implement that functionality is simply going with the catch shape like previously, connecting the failing or the part of the integration that we are expecting to fail to that catch shape. But now, rather than, let's say, doing that send alert functionality and then just ending the process, we actually now do, let's say, that similar SQL query, because if you remember, we have that all of the normal integration functionality available to kind of recover from that situation. And of course, what we can do is we can have decisions, we can have multiple steps, kind of like creating that recovery path. So I could, let's say that if this fails, then we need to do these 4 functionalities and then come back and continue with our normal execution of the integration. And the only thing that you are not allowed to do is you are not allowed to skip basically to the next step here. So if you try to actually say this, well, we have a lot of validation error here, but this, if you try to do this, so basically you try skipping some part of the process, basically with the exception handler, that is not allowed. And you always either have to end the process or the exception handling curve or return back to where you actually were going to go originally in the first place. Moving on to our next scenario. So sometimes we have these use cases where, or actually quite often we have use cases where the data itself is incorrect within our integration. And what that actually means is that we have basically two different main approaches to deal with these sorts of erroneous data situations. One of them is, of course, validating the data manually with a schema or any other value, let's say, evaluation or validation tool. And it could be just a simple validation, like, let's say, checking that, like I said, that the SQL server returns more than one row, or it could be validating an incoming order with an XML schema. But there, the basic use case is quite simply something that we should be quite familiar already. So if we are, let's say, reading in that order file, and we just apply as a logical step in the integration flow, for example, XSLT validation or XML validation using XSD schemas to determine if that order file is valid XML or not according to our functionality. And of course, now the validation step will go into an exception state if our input XML isn't valid or our order isn't valid data, which means that then we'll have to implement that exception handling logic using those tools that we learned on the previous use cases and slides to deal with that validation error. One key thing that maybe not a lot of people are familiar with, especially if you're looking at the kind of low code aspect of Friends where we could be doing mapping, let's say, with our order data that we're actually reading in, maybe validating that and sending it to an ERP. What we can also do then is apply basically that C# code functionality to those low code mappings where we are mapping that order data ID or order amount, product ID, blah, 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 whatever we need, using these nullable operators, so question marks in our references. And there's basically a lot of documentation and not quite nice guides and kind of concept explanations on basically Microsoft's own .NET and C# website on how to utilize these correctly. But for a brief explanation, the most typical use cases might be that we are missing altogether, let's say, the description element in the incoming order. And you might have ended up in a situation in your own Friends development where you are missing some data field where you're doing a low code reference, and without the question marks present, the integration will of course fail. So that part of the integration where you are doing the mapping will go into an exception state because you are trying to basically do a mapping against a data or a data portion of the data that doesn't exist, but we have options to deal with that. So that actually means that we could put in a question mark before the reference to our desired field. And what the question mark is actually telling the Friends process is that if the description is missing, let's not end that part of the mapping in an exception, but ignore that we are missing that description value. And instead, what will end up happening is that we will end up with a null product description because it wasn't available. But also quite typically, we might have the kind of default behavior. So what I could also do is that I could say that if the ID functionality or the ID is missing here, by adding in those double question marks and then providing some sort of a value or C# code functionality, such as in my case, the new graphical user identifier here, we are actually telling Friends that if the ID is missing, let's actually generate a new one on the fly. So basically, if we are missing the value, what should we do instead? And kind of provide the default option basically as a fallback in the case that we are missing this value. And of course, as a side note here, what we can also do is add in those question marks to maybe the data element here or the order altogether. So as we are traversing, let's say, our source data structure, for each and every reference that we are separating with a dot, we can kind of say that, okay, if the whole data element is missing, let's ignore that altogether. Or maybe we might even have a case where if the order element is missing, well, let's ignore that and then just put null everywhere. So quite a lot of options for us to now either validate the data so we know that the data will have the correct amounts and correct functionality present, or then deal with those cases where the data is either incorrect or we are missing the data altogether. And lastly, but not least, the silence monitoring errors. So now this is a little bit of a different approach to exception handling in general, meaning that we might now have those situations like I explained where we could be receiving orders like we do in this integration example here. And we are triggering the integration whenever a new order is appearing, let's say, on a shared file drive or file disk somewhere. And of course, now, if there are no new orders being created as files to that specified directory, the integration will not go into an exception state. So there won't be any exceptions because there are no executions of that integration. But now we can actually utilize monitoring rules to create these sorts of different silence monitoring or business rule, I would say, checks against these type of situations where there is not, I would say, a technical exception happening, but we can define these sorts of upper or lower limits or the expected behavior for my integration. And as an example, using the order process here, I might now want to define a silence monitoring rule saying that, let's say, every 24 hours, we need to have at least one successful order inserted into the ERP. And if not, then we need to detect that using the silence monitoring or the monitoring rule functionality. And what we can actually do when we are detecting this sort of a problematic, let's say, rule trigger, like, for example, missing the correct amount of orders, we can actually revert back to the global error handler. So we can actually create a sub process that then will be triggered based on that sort of a top-down silence monitoring or monitoring rule approach. A good thing to note here with the silence monitoring and the monitoring rules in general is that you can use this on pretty much any data that's passing through your friend's processes. So you could even do stuff like, let's say, select the duration of your I would say most critical steps in your integration flow, and that could maybe be inserting an order to your legacy system where the legacy system maybe has some throughput errors or throughput problems. So that way, what we could, for example, do in such as we are doing in this example here, is creating a monitoring rule that if that, let's say, order insertion step takes more than 30 seconds, and that more than 30 seconds execution happens more than once every 5 minutes, that should then trigger basically our exception handler, which will of course be able to then alert or create that ticket for someone to actually come in and take a look at what's happening. And what this actually example means is that we are now kind of allowing one execution every 5 minutes to be over 30 seconds. But if we have two, then of course the rule is broken and that will trigger the execution. And similarly, it can be applied to the number of rows in an order or the total amount of euros coming in through all of your order interfaces, or the size of files we are transferring, or pretty much any data that you can capture with a variable inside your friend's process can now be utilized with the silence monitoring errors and silence monitoring rules. And lastly but leastly, in a sense, so maybe some of the best practices kind of regarding the exception handling options that we've covered in the webinar here today. So the global exception handler for the unhandled exception should probably be present in most of your integrations, if not always. And definitely you should have an exception handling strategy in place, meaning that you should probably create a couple of different sub-processes that are handling exceptions in a slightly different way. Maybe one creates business-friendly tickets, one creates technical tickets, and so on and so on, and then choose the correct one for each of the processes that we are actually using in our friends. And then we have, of course, the retry that we covered as the first step. And quite typically, there's usually no harm in enabling the retry. So I would say that the retry is kind of sometimes used, and often I would say maybe 50% of the tasks that I usually implement have the retry functionality. But what you have to take into account that the retry will increase the throughput or the execution time. So don't use retries in, let's say, time-sensitive API operations, because then that can actually result in a situation where normally the API goes in under a second, but then we have 10 retries in 3 steps, and then suddenly it takes 5 minutes to execute, or 5 minutes to actually go into that failed state, which is not very nice for the consumer of the API. So be mindful of the retries and, of course, the increased execution time that they bring in. Then, of course, we have the exceptions for a specific part of the process and throw the manual errors by design. So these are much more rare. So of course, and most often kind of dependent on the use case and on the design of the integration itself, and are not something that should be automatically enabled and included in your development patterns, and should always be considered, should I do this here? And if so, what am I trying to achieve? And these are kind of the, I would say, more advanced functions for the exception handling. And kind of finally, of course, well, I have the zero depends here for the monitoring rules, since this is also something that is completely dependent on the use case and the requirements. And quite often these requirements might actually come from the business side, or you know that this is something that you need to kind of monitor, or you know that this is something that when this condition is met is actually an error. So not something that's always included, but a quite useful tool nonetheless. And that was basically all of our time today for the presentation. Everyone have a great day and see you next time. Bye bye.